All right, let's get into it. Today we're doing a deep dive on a pretty serious piece of kit. It's the NTI E-16D-24VDP.
That's a mouthful.
It is. But our mission here is to really unpack how this one box acts as a technological sentinel for places you can't have people watching all the time, like data centers or remote server closets.
Right. And we're not just talking about a simple thermometer here. This thing is designed to be the central nervous system for that infrastructure. We're looking at temperature, humidity, water, power.
Intrusion, smoke, the whole spectrum of what can go
The
wrong.
whole thing. Exactly.
And the capacity for inputs is, well, it's huge. You get 3 internal sensors right away, but it supports 16 external ones you can configure, plus another 8 digital inputs.
Yeah. And those are for simple things like a door switch or, a float sensor for water. Which brings us right to our first layer, comprehensive sensing and redundancy.
It's not just about the number of sensors, is it?
No, not at all. It's about the precision. The internal humidity sensor, for instance, is accurate to within plus or minus 5%. That kind of accuracy can warn you about condensation issues long before you ever get a full-blown water leak.
Okay, but let's talk about the real weak point in any enterprise system. Power. I see this has a 1-hour internal battery. And honestly, 1 hour on a lead-acid battery feels a little risky for a high-stakes environment. Is that really the safety net?
That's a great question, because it's not the safety net. It's the last safety net. The philosophy here is triple redundancy.
Triple.
The unit supports dual power sources, AC, 48 volt, 24 volt, whatever you have. If the main power fails, it instantly, automatically switches to that second source. Only if both of those external power supplies fail does it finally kick over to that 1-hour battery. So you're really buying time to fix 2 simultaneous major failures.
That completely changes the calculation. Okay, so once it senses a problem, how does it go from detection to, panic mode? Let's move to layer 2, the alert systems.
It definitely doesn't put all its eggs in one basket. You get your standard network alerts, of course, email, a web page notification, that sort of thing.
And SNMP traps.
And SNMT traps, which feed right into your main enterprise dashboards. But what if the network itself is down?
Good point.
That's when the physical alerts kick in. You've got LEDs, a very loud alarm beacon, a siren. It can even use an external modem to send SMS text messages directly.
So even with a total network outage, you're still getting a text that the server room is flooding.
You're getting the message one way or another.
But it's not just about screaming for help, right? I see it has 4 output relays. It can actually act.
Exactly. This is where it gets really powerful. Those relays can control fans, pumps, whatever you wire into them. And you can define how they respond using what's called the Smart Alert feature.
And what's that?
You can create up to 20 custom alerts based on combinations of up to 50 different events. So if the temperature goes up and the voltage drops, for instance.
A complex failure.
Right. The system can then send actual SSH commands to connected servers.
Wait, SSH commands, as in it securely logs in and runs a script.
Precisely. It can trigger a soft shutdown or a graceful reboot. It's actively preventing catastrophic hardware failure or data corruption before a human can even get on site. It becomes a participant, not just a referee.
That's a game changer. Okay, let's jump to layer 3 then. Enterprise integration and security. This thing is obviously built to scale.
Oh, absolutely. You can cascade up to 4 of these as slaves to one master unit, all connected with standard network cable over, get this, up to 4,000 feet.
And you manage all of them from one web interface.
A single web interface.
Yeah.
And it plays nice with the big open source monitoring tools that a lot of IT departments love, like Nadios and MRTG. It can also ping up to 64 other IP devices on the network just to make sure they're still alive.
So with all that remote power, especially SSH access, security must be a top concern.
It has to be. And it is. It's using HDTPS SSH version 2 AESS 256-bit encryption for all its communication. It supports LDAPv3, which is critical for tying into a company's existing user directory for access control.
So no separate passwords to manage?
Exactly. And for email, it supports XOA-UH2, which means it uses secure, modern tokens for authentication instead of, old-fashioned passwords that can get compromised.
So wrapping this up, the NTI E-16D-24VDP is really designed to just remove uncertainty. It's a redundant multi-protocol workhorse for places you can't afford to have fail.
That's the bottom line. But here's a final thought I want to leave you with. This device has a stated mean time between failure, or MTBF, of 39,685 hours.
That's, what, over 4.5 years of continuous operation?
Over 4.5 years. So think about this. When an architect is designing a multi-million-dollar data center, they rely on that specific number. So how does the stated reliability of this one single monitoring device shape the entire operational budget, the insurance policies, and the risk tolerance of a massive enterprise? That number isn't just a spec, it's a foundation for trust.